All right, guys, I'm going to go over the real number system worksheet that I gave you. Okay, first things first. Any and every number is going to be that real number. We took these notes yesterday. So every number that you can think of is going to be a real number. That means that the negative square root of 17, make this darker, negative square root of 17 is a real number. So I'm going to put a check in the real number box. Negative 2 is a real number. A negative fraction, it's a real number. 0, real number. A negative decimal, real number. Repeated decimal, real number. A decimal that has those dots on the end, that's a real number. 18, real number. Even though the zeros on the bottom, this is undefined, it's still going to be a real number. Pi, that's a real number. Repeated decimal, this is a decimal right here, real number. A perfect square root, real number. This is a decimal, terminating decimal, it stops, that's a real number. A perfect square root, real number. A negative perfect square root, real number. All of these are real numbers. Any and every number is a real number. Okay, so now we're going to go back to look at the negative square root of 17. Negative square root 17. Negative square root of 17, we ask ourselves, is it going to be rational or irrational? There are only 3 kinds of irrational numbers, okay? Your non-perfect roots, your pi, because it's about 3 and 1400ths is not exact because that decimal goes on and on and on. And that's the reason why we say irrational. When you say something is irrational, it's unpredictable. Okay, since we don't know what number's coming next, that's unpredictable. It's irrational. Here, non-terminating decimals, decimals that don't stop, that have those dots at the end. These are your 3 irrational numbers. Everything else is going to be rational. So let's go down the list. All right, a negative square root 17. It's going to be a non-perfect root, so that's irrational. Then we have negative 2. Negative 2 doesn't fall in any of these categories right here. It's not a non-perfect root. It's not pi. And it's not a non-terminating decimal. That is very rational. And by definition, a rational number is also a number that can be written as a fraction. So this is definitely rational. Now we got a fraction right here. So that's definitely rational because it's a fraction there. 0 is going to be rational. It doesn't fall into those 3 categories, so it's rational. A negative decimal, it's not any of these 3 categories. It's a decimal, but it stops. It's not a non-terminating decimal. Decimals that don't stop. It stops, so it's rational. Repeated decimal, we know what's coming next. It's predictable, so that's rational. This decimal, where you have the dots at the end, like to be continue in a movie, this is unpredictable. We don't know what's coming next. That's going to be irrational. Not rational, right? 18 can be written as a fraction. It's very rational. It does not fall in any of these groups, okay? This is undefined, so this is going to be irrational here, all right? Pi, irrational. It falls into that group. And this one of the, let me back up. This is one of those special cases. You know, it's always somebody or something that's going to be special. So even though it looks as though it doesn't fall in this category, because it's undefined, that's what makes it irrational. Okay, so here we got this pi is irrational. Then here we got a decimal, and it's a repeated decimal, but you know what's coming next. It's rational. This is a perfect square root. This is equal to 15. The square root of 225, that's 15. So that is going to be very rational. A decimal that stops is a terminating decimal. It's rational. And here, the square root of 4 is 2. The square root of 49 is 7. So that's 2 over 7. That's going to be very rational. And the negative square root of 64, that's a negative 8. So that's also going to be rational. It does not fall into these three groups or categories. So that's what makes it rational. All right. So we have taken care of rational and irrational. Now, notice if a number is irrational, that's all it could be. It's a real number and irrational. It can't be anything else, just real and irrational. So the ones that have real and irrational, you're done, okay? Your rational numbers are broken into two groups, okay? It's broken into your fractions or decimals, or your non-integers, or your integers, whole numbers and their opposites. So all of your fractions and decimals are non-integers, not an integer. So they're in a group by themselves. And then your integers are whole numbers and their opposites. Okay, whole numbers and integers, they do not have fractions attached to them. They do not have decimals attached to them. Do you see that? This symbol that you see here, we talked about that when we did these notes. That's a negative infinity. That means it continues forever in the negative direction. And remember again, integers do not have fractions and decimals attached to them. This category over here, the non-integers, are where the fractions and the decimals go. Okay, so let's look at if a number is going to be an integer or not. So we're looking at just integers. Remember, if it's irrational, it can't be anything else. So we're done with this one. All right, it's rational. So we have to decide, is -2 an integer? Yes, it's an integer. It doesn't have a fraction attached to it. It doesn't have a decimal attached to it. It is a whole number that's opposite of a whole number. Well, that's opposite of 2, which is -2. So that makes this an integer. All right, too hard. 0, okay? 0 is also an integer. Does not have a fraction or a decimal attached to it. This number right here, -6.06, that has a decimal attached to it. It is not an integer. 4.56 repeating, or 56 hundredths, that has a decimal attached to it. It is not an integer. Okay, we already said that, look, if it's irrational, it cannot be anything else but real and irrational. 18. 18 is an integer. It doesn't have a decimal or a fraction attached to it. Okay, undefined, this is a fraction. That's all, look, that's all it can be. Oh, yeah, that's right. Irrational, it's real and irrational. Sorry, so that's all it could be there anyway. Real and irrational, that's all it could be right there. Nothing else. If it's real and irrational, that's it. No more categories for that number. Let's look at this one. It has a decimal attached to it. It's not an integer. Let's look at this one. The answer is 15. 15 does not have a decimal or fraction attached to it. It is an integer. This decimal, it's a decimal, so that means it's not an integer. And this is a fraction, so that means it's not an integer. 2 over 7 is not an integer. And then we have a -8. It does not have a fraction attached to it. It does not have a decimal attached to it. It is an integer. Okay? It is an integer. So now let's go back and look at the others. All right, let's look at the ones that have integers beside it. Because remember, look, now we own integers. Integers are broken into two categories, like we talked about on yesterday. It's either going to be a negative number, numbers that are less than 0, or a whole number, okay? Negative number or a whole number. Negative numbers are numbers, again, less than 0. And your whole numbers, again, do not have fractions or decimals attached to them. It starts at 0, and it goes to the positive infinity, which is a positive sideways 8. That means it continues without end, and it's all numbers that do not have fractions or decimals attached. So let's look and see which of these numbers, these integers, are whole numbers. So we're only looking at the integers now. Okay? And why did I put an X there? You know this is wrong. Miss Ray, see how I'm making mistakes too, guys. So sorry, baby. All right. So look. This is an integer. It is also a whole number. Whole numbers start at 0. Not an integer, not an integer, not an integer. This is an integer. It is also a whole number. 18 is a whole number. Okay? Not a This is an integer. 15 is also a whole number. Okay, this is a fraction. Okay, it's a negative number that doesn't have a positive, that doesn't have a fraction or decimal attached, but guess what? It's a negative number, so it's not a whole number. Remember, whole numbers start at 0. So that is not a whole number. It's less than 0. So now we're going to go, look at this. Whole numbers are broken into 2 groups. So we're just going to look at only the whole numbers. 0 is in a category all by itself. And you got your natural numbers. Your natural numbers are counting numbers. So we're looking for the numbers that are counting numbers. Whole numbers that are counting numbers, okay? So here we go, because that's the last category here. So we got this whole number is not a natural number. You don't start counting with 0. When you count the quantity of something, you do not start counting by saying, oh, that's 0, 1, 2, 3. No, you say that's 1, 2, 3, 4, so on and so forth. Okay, let's see. Looking at this whole number right here, 18. 18 is a counting number, so it's a natural number. Let's look at this whole number right here. 15 is a counting number, so it is a natural number. Let's look at no more whole numbers on this list. So this is what you should have. Filled in there, okay? And if you have questions, just text me, okay? All right. Bye, y'all.